Hi, everybody. I thought we'd do a little bit of new stuff until Tuesday. At least it'll give you something to think about. And what we're going to do tonight is take a look at some things that'll happen if you get stuff that is out of control or violates the runs. And I think you'll find this interesting. So let's take a look at a data set. Um, and I will put this, you'll see when I have the movie up there, I'll have these up there as well. So, what I did, well, this is stolen from your book. They took a sample from cigars and looking at deviations from cigars. So, what we will do is call this CIG1, and we'll have our matrix as usual. And we're going to scan um, cigar1.txt, and the number of rows, my fault, the number of columns is equal to 5, and by row is true. So we are going to do our range chart. So we have QCC, and we have CIG, and we have type equal capital R, and we have number of columns equal 4, or my fault, 5. So right away, let me puff this up. You notice we have a number violating limits. When we say that it's violating the limits, we say that it's out of control. So right then and there, we know that we can't do the X bar chart. So if this was a real life situation, we would go in and see what's going on. Maybe there's a problem with a machine. Maybe there's a probability with an operator. Maybe there's probability with, maybe there's a problem with raw materials, something like that. Okay, so just for argument, suppose we went in and fixed whatever it is that is wrong. And what we're going to do is run several more batches and see if we fix things. So we have another data set, and we call this SIG2. I'm going to be lazy and just up arrow. And it still has 5 columns, still by row equal to true. Okay. Now, we're going to have 2 data sets in the same thing, in the same function. So this is pretty slick. I think you'll like this. Whoop. So you'll have the first data set. Now you're going to have the second one. So you're going to put in new data equals SIG2. Then you're going to have new sizes also equal to 5. So this tells it where to go to get the second set. Now we'll see what happens. Okay, so you've got the calibration data. That's your first set. You still have the red mark there, the out of control. That's okay. We don't worry about that anymore. But now, let me go ahead and expand that. With our new data set, we're violating the runs. Okay, so we've got the 6, 1, 2, 3, 4, 5, 6. But then we've got a bunch still above the line and above the control, or excuse me, it would be the R bar bar, and between that and the upper control limit. Therefore, even though we've made our fix, it's no good. So we need to go back in and fix it again. So we don't need to do our our X bar chart. All right? Isn't that interesting? Good. Let's take a look at another example, shall we? Good. Okay. Let's look at excuse me. Let's look at some thickness of layer of steel, and we'll start out as usual. So we have thick matrix scan, and it's thick 1. I know, how clever the title of these. And the number of columns will be 4 in this case, and by row is true. Okay. All right, so we'll do our range chart. And number of columns equals 4. So we're real happy here. This looks nice. So we have 20 groups, nothing beyond limits, nothing violating runs. So this looks pretty good. Let's go ahead and run the X bar chart. Aha. Okay, so here in group 18, we are violating the limits, so we have an out of control situation. So that means we have to take a look at some stuff. So here again, we'll take a look at the steel process itself. Maybe there's a problem with the raw materials, with the process, depending on what's going on. Okay, so here again, let's assume that we fix whatever is wrong. We take another set of runs to see if we've corrected the problem. That's always good. You always want to make another set to see what's going on. And we're going to call that thick 2. We have another file. That also has 4 columns in it. So what we have to do, we don't have to run the the range chart again because that was happy. So what we have to do is put in new data equals thick 2 and new sizes equals 4. Okay, there's our calibrated data. That's okay. Then our new data set is fine. So we corrected whatever it was that was wrong. So we're in fine shape. Okay, good. Now when I put the movie up, I'm going to put the data sets up so you can practice this, just so you can see if it works itself yourself. Okay, thanks. Hope you enjoyed this.